Cool countdown. we're live. Hello, everybody. What's going on, Siam? What are you talking about? What are you talking about today?
Yeah, I think we'll be talking about more and more GPUs. I know last time we talked about you did a cool demo on Olama running on your hardware kit. Uh, Today, probably we'll talk about some of the multi-tenancy architectures, some of the challenges which are there on the bare metal GPUs, how to architect them, and then some of the solutions which revolve obviously around vCluster and how it can help in architecting the infrastructure with the isolation and efficiency in mind. Yeah, this is what we're talking about today. Bare
Awesome.
metal Kubernetes with GPU, architecting GPU infrastructure with isolation and efficiency in mind.
So yeah, welcome everybody too. Yeah, thanks for the comments and stuff too. I'm excited about the session. Yeah, if you have any questions or anything, let us know. Like, ask questions is interactive. We're just kind of hanging out and talking about GPU stuff. Like, all this stuff's kind of new for people. I hit my head against the wall yesterday for like 8 hours trying to get the Kai scheduler working. And I think it might be related to me having a 5070 Ti and it's trying to install a different driver, right? If you've tried any of this GPU stuff, you've probably tried to wonder like, oh, do I have the right driver installed? Do I have the right toolkit installed? Am I using the right version for everything? Am I getting mismatched and all that stuff? So it's all that stuff's super complicated once you start playing with it. I guess once you understand it gets a little bit easier. So
Oh yes,
I'm hoping to get there.
the landscape of especially with respect to the open source tooling is actually maturing.
Yeah.
And the NVIDIA drivers, and it's really hard. Like the bare metal is hard, cloud is fairly easier. Like when you create a we were just discussing before we went live, like when you do a GKE cluster and you attach a A100 on top of that, it automatically gives you the option to time slice it. Like, you can slice it by 7 slices and then you can give the GPUs, and then it automatically installs the NVIDIA drivers and attaches the node to the cluster. But when it comes to the bare metal side of things, then you are the one who are responsible to do everything.
Yeah. And the thing too that you think about is, okay, so I'm a systems administrator and I'm standing up a node with a GPU that I'm going to give access to like a VM or something like that. I have to install the driver, I have to install the toolkit, I have to make sure everything's kind of working together. That's the idea that you come from when you're like trying to get this GPU stuff working. But in reality, like what NVIDIA has done is they've created the GPU operator, which I said that word, but the GPU operator. And what that's going to do is you bootstrap your node, you bring it up, you don't install any of the NVIDIA drivers, you add it to your cluster, and then the NVIDIA GPU operator will check that node, see if there's a GPU. It'll stand up the driver, the toolkit, and all that stuff, and configure all that stuff for you, right? If you can get it to work. And it's just making sure like you're using the right version of the OS for the base OS, making sure that you're using a graphics card that's supported and all that stuff too. So that didn't exist, 4 or 5 years ago, right? Like, and now it does, and it makes it a little bit easier to get stuff stood up. But still some headache in there trying to get it all configured and understanding where everything runs at each level, and then the different types of isolation.
Yes. So just want to give everyone who is listening and everyone who will be listening later on a bit of a heads up. These are some of the architectures that we have deduced from our conversations with the customers. So vCluster is proving to be the best fit in the bare metal Kubernetes and bare metal GPU ecosystem. And we are talking to a lot of customers in that space, and from that only we have learned that, okay, these are the pain points and this is how vCluster is able to solve that problem. So this whole presentation will be around that. But if you have any additional architectures, just like Mike pointed earlier when he was starting the stream, if you are using GPUs, you're running inferencing on that, you're running training on that, would love to hear about your GPU architectures, your GPU, bare metal GPU, Kubernetes clusters, pain points, and wherever you can post on LinkedIn or StreamYard or YouTube or wherever you're watching it live from, or you can also even join our Slack and let us know, okay, this is some of the stuff that I'm using and this is where I'm facing the problem. Can vCluster be one of the solutions? I'm pretty sure if the problems are related to what I'll be showing, vCluster will be the right fit for those set of problems.
Yeah, I want to know what people are using it for, right? Like, instead of me just running like an LLM and just asking it questions and saying, I don't like these results. Like, what are you using it for? Code completion?
Yeah, exactly. The use cases are pretty important. Like, so yeah, this is me. Probably you know me, but if you don't know, like, I'm working as a principal developer advocate. Mike is on my team, and also I'm the CNCF tag, operational tag resilience.
I'm gonna reshare it real quick, Sam, because it's like adding like we got this little thing. All right, I'll figure that out. We have like a little like thing here at the bottom of chat, maybe.
Oh, okay. Oh, I added that actually. So it's a new feature in StreamYard where you can add a live comment section.
Leave it up. All right, sorry about that.
No worries. So what's happening? The AI use cases. Obviously, we know we are beyond the hype now. Like the hype came in with the chat GPT, but we are all after the hype now. We are into the real use cases of AI. Like everybody has started to simplify their workflows. Everybody has starting to build applications, AI application that helps in a certain area, whether it's content, whether it's building out applications, whether it's IDEs. Like people are trying out different use cases, and with the use cases, the complexity is increasing. With the both of them increasing, the GPU demand is increasing. So one of the key things that is happening is people are moving these GPUs to on-prem rather than having them on cloud. There are different reasons for that, which I'll touch on if there is a slide on that. Let me just quickly check. Yeah.
To submit what you just said too, like here's a question. How many of you have had a CEO or a different person in executive leadership start talking about using agents, right? Like, or start talking about, hey, we need to look into like what we're going to pay for like a code completion, that kind of stuff for our developer team. Like, how many of you heard that? Oh, we need to start making agents, right? Like, because that's kind of the thing that's been going around is like, we need to start working on agents. We need 24/7 employees, like that kind of thing, stuff that can extend you or your work outside of like the normal day.
Yes. 2025 is the year of agents, right? So one of the key reasons why people want their infrastructure and the models, the open source powerful models running close is, one, they want data closer. They want their infrastructure closer to the data that they're having. Second key reason is they want security. So they want all the secure access for their data that LLMs are using. Like there have been a lot of breaches. You can read it about online, the security breaches that happen when you put the data online. And if you see all the companies, if any of the companies is actually giving access to their employees, they're actually deploying a version of the LLM, and then they are giving the access, restricted access or the access on their own hardwares. And this makes sense, and which is why people are buying hardware from NVIDIA. They are putting it in their data centers or creating those mini data centers, and then try to create Kubernetes clusters out of that and attach GPUs. That's what is happening. But what do people need? The people needs the infrastructure that scales. People need batch processing because ML ecosystem requires that. Resource management, one of the key things. Obviously, we talk about DevOps, ML ops, AI ops. So we need that whole ops cycle integrated into that. Training and inferencing. So the whole, the whole machine learning life cycle that is there, from starting from the training to the inferencing. This is what is needed. So, and then you have AI for the teams.
You a little bit darker side.
Yeah, I know.
Yeah.
The light went off, but the internet connection will stay. So I'll just keep continuing. The light will come on. One of the key reasons why Kubernetes has become, the hot favorite in running or managing or the base for the infrastructure running your AI workloads as well, because all the big companies, all the top companies, I would say, in the AI space have, trusted Kubernetes as the ecosystem, as the orchestration system, as the infra layer, as part of their infra layer for running these machine learning workloads. So there was this very interesting talk that OpenAI gave at KubeCon, and they also mentioned it in their blog post that how they scaled Kubernetes clusters to 7,500 nodes, producing a scalable infrastructure for large-scale model. And I think yesterday there was yesterday or day before yesterday, AWS mentioned how they are scaling that infrastructure way beyond what we are seeing the number over here. I think it's 100,000 nodes.
Yeah.
Like, you can see the amount of scale that people are taking Kubernetes because the demand is the AI, a new AI that is being developed, the new applications that are being developed, the hunger for those applications is that they demand these massive clusters. And specifically, they have targeted that these are the next set of platforms for your AI infrastructure. So from 7,500 to 100K, that's the journey that we are seeing, and how even the cloud providers are working towards making their Kubernetes engines compatible enough or scalable enough so that you can run the AI workloads.
But what does that mean
And
for end users, right? Like that means people are going to be using these things, and you're going to compete even more for like GPUs because people have the scale they can get to, and they can just use the cloud providers, or they do it on prem because they're
exactly.
competing for GPUs, right? Like, and they want to do it all on site.
Also, one more reason I forgot to mention why people go for bare metal, because there they have the access to the GPUs. On cloud, it's so difficult. Like getting a A100 on GKE is a struggle. Trust me, I've gone through the process. You struggle between the regions, and you are still not able to get the A100. You have the capacity, you have the quota, and it's difficult. So it's difficult to get the access, and you never know, when you need, will you get, which is why also people need dedicated systems for what they are doing. So the whole life cycle, why AI workloads need Kubernetes is for the whole life cycle, not only for the inferencing part. Developing, training, deploying, serving, monitoring. There are amazing tools like Kubeflow, MLflow, Seldon, Kserve, Argo workflows, which are already there, that helps you out with all these things. But what's happening, so yeah, this is what's happening. So what's happening is Kubernetes trend for bringing GPUs into the bare metal setups for the AI and the LLMs are on a very steep rise, as per our conversations with the enterprises that we have been talking to. This is the trend that we are actually seeing. So this is not a hypothetical trend, this is the actual trend that we are seeing. Now, the biggest problem is when you have the infra hardware, because now we are talking about the bare metal. Now we are talking about the hardware. Now the hardware is with us, and the hardware is limited. It's finite. You can count the number of GPUs that you are having. You can count the number of nodes that you are having. You cannot make a single request and add a node just like that. So it has to be very carefully designed for different teams. And in an organization, especially in an enterprise, you won't be having a single cluster dedicated only to a single team. That's it. No, there will be multiple teams, like many teams doing different set of ML use cases. Some might be on the training side of things, some might be on the inferencing side of things, and also if for a single application, there might be specific segments for which you are developing the AI for. Someone is working on an agent X, someone is working on an agent Y, and they both want separate Kubernetes clusters for both that agents for their whole machine learning life cycle. So how do you do that? So for different teams, running the AI workloads becomes a challenge when it comes to bare metal.
To add to that too, to even make sure that like you're using that node fully, you also are going to have non-GPU workloads that could be running there too. It depends on how much you can actually scale up on that node, right? Like, so you've got a mix of all of these things and additional schedulers and all these other things that you're going to add in.
Yes. And just to give you a context, one cluster, if you are doing a non-HA cluster, so that at least one node will be there as your control plane node. And then you'll be having 3 more nodes as your worker nodes where you'll be deploying the workloads. And let's say you have 20 different teams. So you'll repeat the same setup 20 times. And you can imagine 2360 nodes only as the worker nodes, and then 10 nodes, 20 nodes as the control plane nodes. So you need to have that 70 node of infrastructure with you. Out of that, maybe 10 are GPUs, 20 are GPUs, and 1 GPU is given to every team. And maybe some of the teams are using, some of the teams are not using it. So it's getting wasted sitting over there. So these are the kind of setups that limits the performance and the resource. So yeah, I'll go to the challenges. So limited tenant isolation. Yes, you can do the namespaces stuff, but we all know that namespaces isn't enough when it comes to the controllers, when it comes to CRDs, when it comes to the autonomy, when it comes to multiple namespaces by multiple teams. How do you limit that? The process is highly manual and complex. Then you have the compliance. So how do you make the compliance work across different namespaces and stuff. Obviously, the operational complexity and cost, if you are doing it in a multi-tenancy mode, in a non-multi-tenancy mode and only the namespace based, how do you scale that? How do you add a new, like, let's say a new team comes tomorrow? What do you do? It's not easy process. Yes, you have to write extensive bash scripts, and you have to do that process. You have to monitor that. You have to do all sorts of things. And also, every team have their own choice of DevOps tools. Every team wants, and not every project is compatible with every version of the application. Some might be compatible with a newer version. Some might be compatible with the older versions of the applications. And by applications, I mean applications like Argo CD, applications like Postgres, or whatever you deploy on the Kubernetes cluster. So how do you, manage all those things would be very difficult in the namespace-based multi-tenancy mode. So let's look at Mike, you want to say add anything?
Yeah, so I would say like that last slide, like the perfect part about the last slide too is that we're just talking about Kubernetes here. We're not even necessarily bringing in GPUs to this at all, right? Like GPUs add another layer of complexity.
Yeah, this is general.
Yeah.
Yes, this is actually the general problem.
Yeah. So you're just thinking about this when you have Kubernetes, like I don't even have GPUs yet. Like, but then as soon as you get GPUs, you add even more information to this. How do I schedule? Yeah, which I think I'm kind of talking about what you're going to talk about in a minute.
So yes, that's the current architecture that you will follow. You order some hardware, you get it in your labs or offices or wherever that is, garage, and then you install NVIDIA operator, and you have those GPU nodes. You prepare a cluster. Now, as easy as it looks here, Mike can tell you that
Super
it's
easy.
not as easy as it looks here.
Well, to be honest, I'm also doing like consumer level stuff, right? Like I'm using the 5070 Ti. I'm not using, an A100 or something like that. So maybe the support's like a little bit better and built in for the data center stuff. Like I'm just messing around at home using older, cards too, like a 1080 Ti. So I'm gonna play with that later today.
So you got those expensive, by expensive I mean like really expensive GPU nodes, and there is a problem of how you share those GPUs. Now in Kubernetes, there are some fine tunings that you can do. Okay, you can have NVIDIA GPU operator so that your pods are able to access the GPUs and stuff. You can have something like Kai scheduler. So Kai scheduler is an open source project, and it is by NVIDIA. So if you go, you can actually check. It's open source native
we had
scheduler.
A question too. So does vCluster work with Talos Linux Kubernetes? I believe so, right? As long as it's a regular distribution of Kubernetes, it should work on there. Like it works on basically EKS on K3s, K8s, as long as it is a
this has been the question. There was this question previously as well. Actually, Mike, I think we need to try and put out a blog on this, because the problem is, it should work ideally, but Talos is API driven operating system. It doesn't have any SSH access. It has only 12 binaries. So it's a pretty small, trimmed down OS distribution for this. And there have been issues I have seen in the past, because I have extensively worked on Talos. I know the founder, Andrew. Great guy, great team. There are a lot of good friends at Cider Labs, by the way. So yeah, I think we can take this as an action item on us and test that.
Make some content
out. Yeah.
You think is it permission based? Like, is it you need more permissions to be able to install it than like what you're going to give?
Not more permissions. You actually can't do a lot of stuff on Talos Linux.
Oh, okay.
So that's the thing.
Oh, it's okay. But, yeah, we're here to interact and discuss. Like, you have questions about vCluster, that's fine. Like, we're talking about vCluster, but we're also talking about like GPUs. So
yes,
I learned something. Thank you for asking the question.
So I was saying that you can do multiple fine tuning on your current Kubernetes cluster. You can have Kai scheduler kind of thing. So regular Kubernetes scheduler is not actually suitable for the GPU kind of workloads, which is why there are projects like enterprise projects like Run AI and the open source implementation like Kai scheduler. And then also you have the batch scheduling CNCF projects like Volcano, which is massively used when you are having the batch processing kind of workloads. So Kai scheduler is efficient. Again, one of the schedulers that is used for resource GPU resource allocation for the AI and ML workloads. Again, it is designed for the large scale workloads and stuff like that. So from previous one, at least this is better. So from this, you learn some stuff. You say that it's kind of difficult, so I want to effectively use the GPU nodes. Okay, you went in for a Kai scheduler. So that's how it is.
And the original,
So
so the original one is using the Kubernetes scheduler. That's the difference between the two slides. Is you're using for your GPU workloads and stuff, you're using just the regular Kubernetes scheduler,
yes,
which could be round robin or just looking at resources that you're not thinking about. Like you go to the Kai scheduler, and the Kai scheduler is going to do something like, okay, first of all, I'm going to give you fractional GPUs, right? Like I can give you fractional GPUs, I can give you memory off of that, and I'll bring up a container and I'll lock it to that GPU in its own namespace, and then your pods will interact with that and have access that way, right? Like it's another version of splitting up a GPU compared to like time slicing and MIG and that kind of stuff, right? So like that's one of the big things. Exactly. Like I know you're going to more, but we'll talk about it too. Like the scheduling is very important. People gloss over it a lot, and they're like, "Well, just the scheduling is different." It's like, well, what does that mean? Some of your slides will talk about that, and I'll talk about it once we get closer to the end, so I don't hijack everything. But you got to think about scheduling different, right? Like differently, and that's why like even the cloud providers may not be the best thing for you to do your workloads on, because you might not have control of where these things are actually running in a rack, to make sure that they're super close to each other and everything has like very low latency. All right, sorry to hijack. I'll once we get through a couple more of these, I'll start talking about scheduling.
No worries. I think that was the right explanation of Kai scheduler, how it helps and how it helps you time slice the GPUs and get those. Because again, as we mentioned, GPUs are expensive. We want to maximize the use of GPUs across teams. So let's try to look at what teams are doing. So, okay, they analyzed Kai scheduler is there, but suddenly they have a problem. And the problem is that there are now two teams. And both of the teams have said that they need a separate Kubernetes clusters. And as the admin scratching my head, I say, okay, what we can do is we don't have any option because we have limited hardware. We'll try to create two Kubernetes clusters, and out of those four clusters, two will be given to team A, two will be given to team B, and I'll set up Kai scheduler on both of them, and I'll set up everything else on both of them, like the NVIDIA operator and stuff like that. Now, the problem arises that in tenant A, the GPU node utilization is very less, which is bad. And in tenant B, it's too much, which is also bad. And now there's a problem that there's a team C, team D, team E, team F waiting for GPUs, waiting to get the cluster access. So it's kind of difficult.
I got a question for the viewers too. So like this scenario that you have right here, right? You have tenant A, tenant B. Say you start with tenant A, tenant B comes along, this other team, like, hey, tenant A is doing some cool stuff. I want that. What is the spin up time between tenant A's cluster and tenant B's cluster when you have to go get more GPU? It's not just buying servers anymore. Like even just buying a server, if you're doing this on-prem, that can take a bit, right? But like going and getting those GPUs, you're not just going out to Fry's or Micro Center or anything like that. Like to just pick these up, right? Like you're going to order it. It might be some lead time for that, right? Like, so you might be like, okay, I can't even do this. What is the option? What is the option to be able to use the same cluster and put more than one tenant on it? I kind of leading you there, saying because it could be like weeks or months. Like who knows how long it could take, especially if there's like a shortage on some of these cards.
So one option can be like Mike mentioned, that there is a lead time in getting those GPUs. There's a lead time in all those things. So yeah, people can try creating those tenant namespaces for every tenant, and then you have the Kai scheduler, and then it is trying to schedule. But it's not an efficient way. Again, we discussed all the problems about the namespaces which are there. So this is where the solution is vCluster, and it not only helps in CPU, but GPU, but also in CPU, but also in both of the architectures. So this is the architecture of vCluster. vCluster basically means you can create a virtual cluster inside the Kubernetes cluster. So what do I mean by that? I mean by that is you bought a bunch of hardware, you have few CPU nodes, you have few GPU nodes, you have storage, everything. You combine everything into a single Kubernetes cluster that acts as your base cluster or a host cluster. Now, you use vCluster to create the virtual clusters for all the teams. So you have team A to team N, you create and those N number of different virtual Kubernetes cluster. Every virtual Kubernetes cluster comes with its own control plane that runs as a pod on the host cluster. And then there is a component which is running as a small process on the tenant, on the control plane pod, which is the syncer pod. Now that is responsible, and that copies, that maintains the sync between the virtual cluster and the real host cluster. And when you talk as, like, for example, like, let me do this. For example, you have tenant A is me and tenant B is Mike. So if Mike is doing kubectl get pods A, kubectl run, the request is going to the control plane of Mike's virtual cluster and not the host virtual cluster. So there is less load on the host virtual cluster from Mike or from myself. And then the GPU sharing becomes effective over here, because now we ideally have our own CNCF certified Kubernetes clusters with us, and we think we are the owner. Just like virtual machines, we think we are the owner of that particular virtual cluster. We can install CRDs, we can do whatever we want to do, and we can create namespaces, we can delete namespaces, and we don't have a clue what Mike is doing. Mike doesn't have a clue what I am doing, although we know what we are doing because we share spreadsheets and where we put our tasks in. But we don't know in our clusters what's happening.
We had a comment too. Wrong answer is only run pod. Yeah. So thinking about that, right? Like the answer is, okay, I can't get a graphics card locally. I can just get a cloud provider, right? But that's going to cost a lot, right? Like, and the margins are getting thinner and thinner and thinner on how much they make off of what, like, they're charging you for those things. Like, what do you think is going to happen in the next like year or two? Like the costs are going to go up. At least I think the costs are going to go up because there's going to be more competition. Everyone's going to want it. Everyone's got FOMO. Everyone's like, I need to get agents going. Like, I need to pay. If you have an agent, what do you need? You need an LLM or something like that to interact with and to be able to actually get stuff to happen, right? Like, you need some logic and stuff behind it. So I need my own LLMs. Can I run that on site? Do I give that to a cloud provider and pay for that? Do I pay for an API request through ChatGPT every single time I want to do something? Like, it's going to get very expensive. So yeah, you could go to the cloud, get it immediately, and you'll have it. But like, I think those costs are going to go up. I might be wrong, right? Like, but we're gonna see some interesting things over the next year or two with how much things actually cost versus how much you're being charged for them. You're getting hooks, right? Like this AI stuff, like ChatGPT and all this, it's literally just like DoorDash, Grubhub. It is Uber. It is operating at a loss, like big losses. Some companies are just gonna keep going, but it's operating at a loss, right? So making sure that you're able to do stuff like this and be able to utilize it and pay less for it, or at least utilize what you actually even get access to, like that's super important. So doing it on-prem like that, doing it in the cloud like that, even using vCluster in the cloud to make this happen, it's going to make it so that you can actually hopefully get more use out of what you're able to actually afford or even get access to.
Yeah, because they correctly said, the thing is, in the end, you will be building some applications that are using these GPUs, using these architectures, and then you want your end users to use it. And you cannot price them high. Like if you take Perplexity Pro, if you take ChatGPT Pro, if you take Gemini, all these tools are there. These are just the very common and well-known examples. I mean, I have all, but yeah, usually you do not buy all of them, and the competition is pretty good over there. You can have that competition, and for that you need to maximize your architecture to bring down the cost that you would charge your customers.
So yeah, add us on LinkedIn, Mike Peterson, Siam. You can put I think you're gonna have like I think you had like a scan thing, but I can put our LinkedIn stuff if you want to reach out, or message me on Slack, Andrew.
Yes. Yeah, we would love to chat more,
Yeah.
Andrew, regarding what you are doing and stuff like that. That would be good to know. And that's what these streams are for, like meeting new folks, getting to know what awesome stuff you people are doing, telling you what we have been hearing from the industry and what we have been learning from you as well. So it's a that's why these are not these are official streams, but when I and Mike are over here, we kind of go beyond the script and we build our own script.
We just interact to talk about stuff. Yeah, so like, and this is vCluster right now. This is just like, we're giving you a snapshot of what vCluster is right now. We're thinking about all this stuff for the future, and there may be things in the next couple of months or years that you see that are different use cases that we're going to answer with vCluster, right? So this is just vCluster right now. So we're telling you how it is now, but there's stay tuned.
Yeah, there is a teaser, by the way. There is a teaser there is a teaser, which I think this might be the first time we are talking about that teaser, to be honest. So there's a teaser. So just wait for one more slide, one or two. So yeah, how it will look like in a data center now. It's a pretty straightforward. You have a data center region, you have physical servers, you have a single large Kubernetes clusters. Yeah, there's something V and N symbol over there, written virtual nodes, which I'll touch later on. But that is another project called vNode. So since you can think of like vCluster virtualizes the Kubernetes layer, vNodes virtualizes the nodes. So very simple terms, you will be able to securely run privileged pods inside your virtual cluster without seeing what is there running on the host node.
Yeah,
That's
tell you what,
what
go launch one of
vNode
these
helps.
containers and do like LSPCI and stuff like that on something that doesn't have something, grabbing that, and you're going to see everything that's on the host, right? Like that's the thing. Is like you don't want your users knowing what's on the host or any of that other stuff, right? Like so you need these layers. Like it could be vNode, it could be like Kata containers, it could be stuff like that to steal that traffic so they can't actually access like the physical server. Because permissions get a little bit interesting when you're talking about GPUs and being able to install stuff on the node with like the GPU operator and be able to access and have information about the UUID and all that stuff about the GPU. Some other stuff could leak out. You don't want that, right? Like so, like you can do a virtual cluster, especially if you trust your users. And that kind of stuff. And like, you're not worried about them having access to see different things on the nodes, like, on-prem, but yeah, containers for nodes. But then like vNode and stuff like this are things you have to start thinking about for that real multi-tenancy on bare metal, to make sure that you're super secure, right?
Yes. And
sorry, I keep interrupting Simon because I'm excited to talk about it. It's like, okay, I'm ready for the next slide.
So that's what we have so much going on within our teams that we cannot share a lot with you. But vNode has been out since I think a couple of months now, and people have been going crazy with the use cases because it adds another layer of protection on top of your container runtime. Like it adds the runtime class, so you get a new runtime class. So you can think like when your request goes to kubelet, kubelet goes to CRI, CRI goes to containerd, containerd goes to your runc, and container runtime, the runc starts the container. So in that, there is a thing called shim. In between that, there is a thing called shim. So this creates a new shim, and that's how WebAssembly workloads also run. WebAssembly runtime also creates a new shim and a runtime class. So with vNode, you get a new shim and a runtime class that actually wraps up your whole that creates a virtualized environment for your virtual cluster to run inside that virtualized node, so that even if you break out of that vCluster on the node, you are still be able to see only what is there on the virtual node and not the actual node.
Yeah, all this is about like controlling information and what gets shared and access, right? Like I think the best compliment I give to vNode, which is the compliment I gave to Kubernetes after coming over from OpenStack, is like, it's boring. It's too easy to get the initial setup, to get the setup going, right? Like, oh, it's kind of boring. Like I just kind of installed it and it just like does its thing. Like I don't have to troubleshoot, do all this extra stuff to get this working, right?
So the next is, this mode is the default mode of vCluster. You have a dedicated mode as well, where you can specify, let's say you label your cluster A with label A, and you label your cluster B with label B, and you have the labels on your GPU nodes. So you can actually specify where you put, where do you want to put your particular virtual cluster. Simple, plain Kubernetes concepts of node selector. Nothing fancy over here. The next thing is pretty interesting, and this will be out in like, I cannot tell you the date, but very soon. So what's
within the next 60
is,
days or something, probably, like hopefully somewhere around there. Yeah.
So you have tenants, and with tenants, what you can do is the virtual cluster can be connected to dedicated nodes, which will act as dedicated Kubernetes cluster. So you can have the same look and feel of this, but you are still having you are still having the cluster, but you are giving them different nodes, and you have them as separate Kubernetes cluster. So this comes where you still want to virtualize the Kubernetes layer, give them to the tenants, and have separate nodes. So dedicated clusters with private nodes is something which is on the very right side of the multi-tenancy spectrum. So multi-tenancy spectrum goes from left to right, where left is the least isolation, starts from the namespaces, and right is the Kubernetes dedicated Kubernetes clusters, which is the most isolation. So covering the entire spectrum, that's the target that vCluster is kind of moving towards. That with the same developer experience, with the same CLI, with the same workings, with the same set of commands, with the same UI, same platform, you are able to mix and match. You can have shared Kubernetes clusters from vClusters. You can have dedicated clusters in the same cluster. Like you can mix and match as per the use case, as per the isolation level you need. You can have vNode where security matters to the most. So you can, and you can only do it with vCluster. There are tools out there that does only one specific small use case out of the multi-tenancy spectrum. But vCluster gives you the flexibility of doing mix and matching of all the use cases using the same CLI.
See, what I want to see happen is I want to see people use this and do stuff like, hey, maybe I don't need a scheduler anymore. Maybe I just bring up a vCluster real quick, give it all these nodes, that job runs, and I take that vCluster away and I take those nodes away because the team doesn't need it anymore, right? Like, and you're constantly creating different sized Kubernetes clusters for these virtual clusters depending on what the users need, right? Like, and what those workloads are. Like, maybe you can do it at runtime. Like, that would be super interesting because you're thinking about a minute versus, like 45 minutes of another cluster coming up.
Yes. So Bare Metal Kubernetes is something that we are very excited about. Some of the, obviously I gave you the sneak peek of the private nodes. That is something we are very, very excited about. That is coming up very soon. We are also present at a lot of conferences. So you can chat with us. I personally will be there at KubeCon India. So I'm keynoting at KubeCon India. So if anybody is around there in KubeCon India, would be happy to chat, meet, and talk vCluster. Another interesting thing is we have been trying out a new series, which is called vCluster Fridays. So it's basically Mike, Scott, or Ritik. Basically our team sits with the maintainer of an open source project, and we try to learn the project, and we try to run that particular project live, on a virtual cluster, like on vCluster. Very simple concept, and we are learning a lot with every stream that is progressing, and we have streams lined up till the mid of August already. So make sure to subscribe to vCluster. And if you right now go to the vCluster YouTube channel, you'll actually be able to see the next set of streams which are coming up. And they're pretty solid.
Yeah, I'll link it.
Pretty good maintainers are coming up. Maybe Mike, you can put a
I'll put the link
playlist
in. But say also, if you're a maintainer on a project and you're interested in coming on and you want to just talk about your project and like how it works with vCluster, just reach out, right? Like, because we're gonna try to plan this like further ahead. We're gonna put it on YouTube. We're gonna put it on like Spotify video and stuff like that too, so you can watch it anywhere. Yeah, if you're a maintainer, let me know. And then let me link the channel real quick.
And the Slack is very important. So if you have the open source vCluster. So by the way, vCluster is open source, just in case you're hearing it for the first time today on the stream. vCluster is open source. This is the community Slack, slack.vcluster.com. If you're interested in vNode, vCluster Enterprise, how it works in production, how it works at scale, you can schedule a demo and talk to our solution engineering team and walk through that as well. And also vCluster you can get on GitHub. Mike, if you can put the link of
I'll put that there too.
GitHub repository. So vCluster GitHub repository, it's open source, Apache 2. If you like the project and if you like talking to us, do start the repo as well. That helps. And that's a vanity metrics, but if you really like the project, then why not start it? So yeah, do start the GitHub repository. And that's, it was fun. That's what we have been hearing about from the industries. Yeah, there is a bit more, but we can't say too many things. But yeah, from the bare metal side of things, bare metal GPU side of things, this is something that we are hearing a lot in common from the architectures, which is why we came up with the concept of private nodes, because that is the requirement for some of the organizations. And I think it covers a lot in the multi-tenancy ecosystem, multi-tenancy spectrum. So if you are using something else, and if you are sharing the same pain points as shared, do reach out to us on any platform. We are kind of active, and we'll try to answer as fast as we can, and based on that we can take the conversation further. But what I'm most interested in, if after this conversation, if you can reach out with your use case, what you
Yeah.
are excited about, what anything, it can be anything, like you are using, what all models you are using, what all use cases you are building AI for, what are you actually doing with AI, what is your organization doing with AI, what are they building, are they building agents, are they integrating them into their products, only that is happening. So just curious to understand the use cases that you are using or building for AI or with AI. That would be really good.
I want to know what schedulers you're using. What schedulers are you using, right? Like, so I'm going to discuss something for a minute before we finish up. Like that's the thing. Like, yeah, the Kubernetes scheduler that does like a round robin and stuff and just puts things on different nodes based on that, right? Like, but when you start thinking about work, like I've been consuming so much NVIDIA talks and then like KubeCon talks and all these other things just to kind of get an idea of how things work so I can get it installed locally. I'm doing all home lab and stuff like that, but pretty much it's similar as doing like bare metal. But the idea with scheduling is like there are so many more considerations. Like people just say, oh, scheduling is different for GPUs, but they don't explain it necessarily except for like an hour-long talk that you watch, right? There's so many considerations. Like if I have stuff deployed on EKS or something like that, how can I figure out which one of those nodes is in the same rack, right next to each other, on the same backplane, and something that I can run all my pods on and have minimal amounts of like slowness between them, right? Like not much latency. How do I do that? I don't. There's going to be ways to probably do that. EKS probably makes it easy, but then if I'm doing it on prem, I've got more control. If I have my own bare metal, I've got more control. I can figure out where those things are on the rack, how close it is to the other nodes, and then schedule like everything that I can. Like say I need 20 nodes for this workload, and those 20 nodes are on a single rack. I can make sure that everything gets scheduled in the same spot. Now they also talk about I need to do health checks all the time on these nodes to make sure that there's no issues with any of those GPUs, there's no hardware failures or anything like that, because I schedule all those workloads on that node and then like 2 or 3 of the GPUs like die or something like that, then I have to stop things, right? Like, or figure out how to reschedule things and make sure that the thing that I'm running is still going to be able to run. Like that's more difficult than what the Kubernetes scheduler can handle right now. And it's things that NVIDIA is building, what the Kai scheduler is, what the Run AI and all that stuff is, right? Like there are real considerations in doing that. I think people were getting Run AI before they even knew what they needed it for, but like after they started messing around, that they realized, wait a minute, I got to figure out how to schedule these things. And on top of that, say SIEM's got a workload that's got, I need 20 nodes for SIEM, and then I've got a workload that needs 20 nodes, and then someone else has got one that's got 20 nodes. How does it decide which one of us is the most important? Which one of us is going to help the business move forward? Like versus like, what am I just doing something that doesn't really matter that much? How do I figure out priority on things? Right? Like SIEM's been waiting maybe now for like an hour or maybe like 10 hours for his thing to run, and my thing is only waiting for an hour, but for some reason like I've got higher priority because what I'm working on is more important for the business. Like stuff like that is what you need to consider too when you're scheduling, right? Like you're not going to just like some like vanity project someone's running and they need all this compute space or something like that because they don't understand that they only need like a little bit or GPU space. Like should I let them run it versus like SIEM? So I have all these weights and stuff, like what team is the most important for like the business outcomes that I want, and then what team is like important for maybe future stuff that I need to like think about. So like you're being able to give people what they need is a lot harder, and also kind of goes into like, how do I feel as a person that is the SRE on this team or the DevOps person on this team or platform engineer about certain teams that like are like, hey, I need access, and I can't get it. So there's this human element that goes into it too, right? So you've got the scheduling that is all compute based, and then you've got like this human element of like, okay, I really need to increase the weights for this team because they've been waiting to get this thing done. It might not match exactly what the business needs for outcomes, but it could help, for whatever they're working on or something that may be in the future. Like there's all these weird considerations you just don't think about when you're just thinking about scheduling apps and making sure that the app's running and there's enough replicas and it's answering HTTP requests and that kind of stuff, right? Like you got to think about where these GPU nodes are, what latency is, how many that you can give access to, and to make sure that you're actually piling stuff into those in a way that you're getting the most use out of it, so that you're not just sitting around wasting like space for stuff, right? Fitting all these weird size shapes, Tetris, right? It's Tetris, but then also like people coming at you being like, hey, I think you should put that there and all this stuff, like kind of over your shoulder. So it's, I don't know, it's kind of fun. It's kind of fun and exciting to think about. I'd recommend to go check out some of the NVIDIA keynotes and some of the talks and at KubeCon, and then hopefully you'll see some of us kind of showing up talking about some of the AI ML workloads and how we can use like vCluster and stuff like that. But I'm excited. So hopefully y'all tell us some stuff about what you're working on, and I don't know. we'll be back and we'll talk about more stuff too, right? Like as we learn more, we're learning more with you too, right?
Let us know what GPU stuff or where you are stuck. Maybe we can try creating content around that space. Like Mike created a video. Maybe Mike, you can link that, like how to run
Let me link it.
the Olama workloads on the home lab. And I just saw the comment from Florian. I want to run some workloads in my home lab and using the 5060. Which one you are having?
I've got the 5070 Ti, and that's what the video that I'm about to post was actually run on. And I'm doing time slicing on it, right? Like I'm having a little bit of issues trying to get Kai scheduler working. Doesn't support MIG, but I'm doing time slicing with it, which time slicing is what we're going to be able to do with some of the older NVIDIA cards, right? Like the Tesla P100s and stuff like that, right? Like whereas the newer ones will support MIG, but I digress. So like a lot of people are using a combination of multiples of these two, right? Like so being able to mess around with time slicing is at least going to give you an idea of how to set that up. Let me link that video real quick while Siam.
That would be good. So Florian, do check the video out on the home lab, because Mike has the home lab set up and he actually did end-to-end demo on how to run multiple Olamas and on the hardware that he's currently having. And then do share what problems you're facing so that we can try to address that as well, because we have the home lab. We know the pain points of the home lab and how it is helping, and it's not a A100. Obviously, it's a smaller kind
5070
of
Ti, yeah. So 16 gigs of memory. Like that's another thing to talk about. Like, right? Why can I do? You can do a good amount of stuff on your home lab, but consumer grade cards, right? Like people were yelling, "Hey, NVIDIA, what are you doing? Why are you giving us like less memory in the cards? Just because DLSS and all this stuff is better." We want to use this for more than just gaming now, right? Like at home, I want to be able to use this to run an LLM. I want to be able to do these other things with these cards. We need more than 16 gigs. So 5070, 16 gigs. You go back, you look at the 3090, that's 24 gigs. A lot of people are just buying old 3090s instead of like the P100s and stuff, because that gives them 24 gigs to run these larger models, which you need larger models to get better results and that kind of stuff, right? Like, and then you start talking about foundational models to build on top of it. So like there's this rabbit hole that you go down where you think, okay, this is just simple. I'm going to add GPUs to my nodes and give my users access. But then you have to understand their workloads. You have to understand like what they're doing. Like it's exciting times, kind of. I mean, let me do one more tangent before we wrap up, because then we're getting kind of a little bit longer than we wanted. Another tangent is like, as a business, what do I need to start thinking about now that everybody's writing agents? Everybody's writing agents to do these things. I was talking to my friend at Open Infra about like how many crawlers and stuff now they're getting in their docs, right? Like they're getting all these crawlers just hitting their docs because everyone's writing their own agent. HTTP requests and API requests are becoming trivial with like N8N and these other things that where you can just write it and it'll help you do all these things. So like the amount of traffic that you might start seeing to your documentation, to your other things, like you need to start thinking about creating LLM.txts to be able to make it so that those LLMs can pull that information from your docs easier, right? Like if you're not doing that, then like maybe you're not even getting indexed anymore, and people are not coming to your website anymore. They're not coming to your docs because they're searching through ChatGPT and these other things. So you need to make it easier for them to consume it. Then you also got to think about, okay, how do I limit all these crawlers from just pulling stuff from my docs nonstop all the time, right? Like it's just weird. Like all these things, especially now that you're in the time of agents, like Simon was saying, 2025 agents AI. I need to start thinking about how do I serve my information about my product, about maybe my internal docs and my other things to people in a way that they consume and get the right information, right? Like you go ask one of these chat GPTs or something like that, or even the smaller models, what is vCluster? It thinks it's some VMware project, right? It's not right? Like so you need to think about like how do I give that information to them easier? Just something interesting that I didn't really think about until like the last couple of weeks is that like talking to the Flux maintainers and stuff, they're actually doing that with the LLM TXT, and then they're writing like NPSs in different ways to make these LLMs interact with them in a different way. So
yes,
food for thought.
Every vCluster Friday comes with a new learning, so I would highly recommend you check out the vCluster Fridays. It's about the CNCF ecosystem of the cloud native landscape. We learn about the open source tooling, and you learn with us and how it works with vCluster. An interesting part is sometimes things fail, and it's interesting to debug them live. And I love seeing live debugging. And when I'm doing it, yes, I'm doing it under pressure, but I want to make that work. So
please don't look dumb. Please don't look dumb. That's what I'm sitting there thinking. It's like, please don't make like look like I'm just touching a computer for the first time now, right? Like, well, being judged by like how I grep if I'm not grepping with like the right like flags and stuff like that, right? Like,
I mean, you are under pressure. Like it's live. You're under pressure. Like I know there are not like 100K people watching, but even if it's 10, it's like there's someone who is watching you.
100%.
So tomorrow,
I cheated a little bit on mine, like because I actually went and messed around with it before I. Okay, so we did Flux. I did Flux on last Friday, and we have obviously other ones. Like if you go back, the KitOps one's awesome and the Kernel one's awesome. But I did Flux last Friday, and literally the first time I ever touched Flux was the Wednesday before. Right, Flux maintainers are great. They kind of help me out. That the documentation is very good. It was very easy to get started and actually get to using it and to deploy a virtual cluster and then apps and stuff into it. Right, so definitely recommend checking those out if you're interested in the project or you just want to learn about projects you haven't heard about. Most of them are in the CNCF ecosystem and stuff like that.
Yeah. And there comes the guy. He is the one who is doing tomorrow. So Scott will be doing vCluster Friday for tomorrow. And he'll be having the cloud native PG, which is the Postgres database for running on Kubernetes tomorrow with the maintainer. So yeah, tune in and
tune in. If you have a project that you want to see, recommend it. If you know the maintainers of the project and they want to get some exposure on there, connect us. We'll talk about it too. Like, because we're talking about open source projects in the CNCF ecosystem and how they work with vCluster, but we also want to talk about the project and like what it does and how you use it and stuff like that too, even outside of vCluster. But then we're going to show you a demo hopefully on how it works with vCluster. So
yes.
All right, Sam, I think thank you so much.
Thank you, Mike, and thank you everyone who joined and made this session interactive. I mean, I love when the sessions are interactive because now it's late my time, so I need someone to communicate with, and I communicate with Mike all the time, so I need more folks. So
you only take my excitement so much. You're like, oh man. All right, thank you everybody so much.
Bye.
All right, we'll see you next time.